Okay, we are going to talk about composite figures today. Composite figures are figures that are just pushed together and it forms two or more different shapes, and you essentially have to create, or you have to find each area individually and then add them together. Okay, so we're going to do this today. Alright, so with a composite figure is a figure that can be separated into regions that are basic plane figures like triangles, parallelograms, trapezoids, rectangles, circles, etc. And we've looked at all those area formulas. To find the area of a composite figure, you're going to divide up the regions and find each area, and then find the sum of all of the areas. Okay, so we're going to just split them up, find each area, and add those together. It says round to the nearest hundredth when necessary. So let's look at number one. I'm going to split this figure up into two different figures. This is going to be my figure 1, and in a different color I'm going to name this figure 2. I'm going to find the area of figure 1 first. Now that is a rectangle, so it's going to be length times width, correct? So we are going to find the length, and we're going to find the width, and we're going to multiply them. So I'm going to take 23 times 12. And that's going to give me 276. It's one of my areas. Now I need to find my next area. So this figure, this is going to be my trapezoid. My area for a trapezoid is 1/2 height times base 1 plus base 2. So in order to find this, I need my height, but I also need my bases. So let's look at the height first. The height goes from one base to the other. It's going to be this area right here, this segment. So if I know that the whole height is 18 here, and I know this height is 12, I could subtract to give me this height, which is 6. So that's my 6. Now here's one of my bases. It's the same as this length, which is 23. And my other base is down here, it's 15. So if I plug that in, I get 114. So I've got to add them. So my area total, 276 plus 114, that is going to give me 390 centimeters squared. Okay, so not too bad so far. Let's look at number 2. I'm going to count this right here. This figure is figure 1. And I'm going to count these figures together as figure 2. I'm going to calculate them together as one whole circle instead of 2 half circles. So if I start with my area of my figure 1, that's my parallelogram. Okay? So that's going to be base times height. So my base would be this whole segment here, which would altogether be 12. My height that connects the bases is going to be 5. So 12 times 5 is 60. Now I'm going to find my area, my second figure, which altogether is a circle, so it's going to be pi r squared. And I know my radius is 6. So I get 113.1. So if I find my total area, I've just got to add 60 plus 113.1 to get 173.1 inches squared. Okay, let's go into the next problem. So I have 3 different areas here. I'm going to name my rectangle 1, my half circle 2, my triangle 3. We'll start with 1. So my area of my figure 1 here, that's a rectangle, length times width. So I don't know my whole length here, okay? So what I do know is that this whole piece is 26. I know that this piece is 9, so is this, which is actually the radius here. So I know actually that this piece is 9. So I could take 26 and subtract 9. That would give me my height, which will be 17. This is my height, 17, or my length. So 17 times my width, which is 9. 17 times 9 is 153. Okay, moving on to my half circle. My area is going to be that pi r squared, but I'm going to divide it by 2 because it's only half of a circle. So I'm going to take pi times that 9, we figured out that that's the radius of it, and divide it by 2. And I end up with 127.23. Okay. And my third area. So it's going to be 1/2 base times height. Now I know my base is the radius of that circle, so it is going to be 9. And I could find my height. I know that this whole height here on the rectangle is 17, and this piece is 7. So if I subtract, I should get 10. So I should get 45. My final step is to add it all together. 153 plus 127.23 plus 45 will end up giving me 325.23 feet squared. Okay, let's look at number 4. Break it apart. This is figure 1. This is figure 2. I'm going to find figure 1 first. So my area is going to be that pi r squared, but divided by 2 because it's just a half circle. So I know my diameter is 16, so that means my radius is 8. So this is going to end up giving me 100.53. Now I've got to find my area of my second figure. It's a rectangle, so 1/2 base times height. So if I draw my height in from the base all the way to the top, I don't know what it is, but I know my base is 16. Just don't know what my height is yet. But I just broke this triangle up into a right triangle now. I could find out what the height is by using Pythagorean theorem. This piece is 8, this is 17. So let's do Pythagorean theorem off to the side. A squared, that's what I'm going to call it, plus 8 squared equals 17 squared. Go ahead and solve. You should get 15. And if you multiply, you get 120. So add your areas together. To get 220.53 meters squared. Okay, make sure you have that written. We're going to go on to the next page. Flip it over. I'm going to let you attempt number 5 on your own. We're going to talk about shaded regions next. So to find the area of a shaded region, you're going to find the area of the entire figure, and then you're going to subtract the area of the non-shaded region, the blank region. Okay? So if you look at number 6, we're going to find the entire region first. So the entire figure is a square. So the area is going to be side squared. So we know the side is 25. So 25 squared will give me 625. Now we're going to find the unshaded region. So unshaded is a circle. So the area is going to be pi r squared. What we need is the radius, which is just actually half of this length here. So it's 12.5. So we're going to find pi times 12.5 squared. Let's go ahead and calculate that. That gives you 490.87. So to find the area of the shaded region, you have to subtract 625 minus 490.87 to get 134.13 feet squared. Okay, so we're going to do that again. So number 7, the entire figure is a rectangle. So the area would be length times width. So I know my length and I know my width. So 25 times 14. And that ends up giving me 350. Now I'm going to find my unshaded region. And that is a triangle, 1/2 base times height. Now I know my base is this side over here, which is the same as 25. So 25, my height is 11. So if I calculate that, I get 137.5. So my last step is to find the shaded by subtracting. So I'm going to take 350 minus 137.5 to get 212.5 centimeters squared. Okay, number 8. The entire region is a half circle. So I'm going to take 1/2 pi r squared. However, I do not know the radius. But I do know I have a right triangle here. It should show you that. So you have to do Pythagorean theorem to find the diameter and then cut it in half to find the radius. So I would have 9 squared plus 21.6 squared equals c squared. So I want you to find c on your own. 9 squared plus 21.6 squared, and then you're going to take the square root. Now that is your diameter, so you have to divide it by 2. So your radius should be 11.7. If you plug that in, you'll get 215.03. Okay. So now to find the unshaded, this is a triangle. It's 1/2 base times height. Okay, this is your height and this is your base. So you're going to have 1/2 times 9 times 21.6, which is going to give you 97.2. So to find the shaded region, you're going to take 215.03 and you're going to subtract 97.2 to get 117.83 meters squared. Okay, so I'm going to have you try number 5 and number 9. Just a hint, you are going to need Pythagorean theorem on both of those, but I want you to attempt those problems. And then I want you to start working on homework 3. You should be quietly working until the bell rings.